Hi everybody, it's Miss McClellan. I'm here to go over notes IM2 2.1.2 with you. How can I organize my thinking? We're doing flowcharts for congruence. And we have one learning goal. Let's write it in the first person. I will be able to use congruence criteria meaning our theorems from last class. Side, side, side congruence, angle, side, angle congruence, angle, angle, side congruence, hypotenuse leg congruence, and side angle, side congruence. And you're going to use those for triangles. Oh, these are congruent criteria for triangles, sorry. Triangles. You're going to use those criteria to solve and prove relationships in geometric figures using flowcharts. First problem, 2-12, examine the two triangles. Well, are they congruent? Well, they have three congruent sides, so yeah, they must be. Yes, they are. Triangle ABC is congruent to triangle. Let's see, what has to go first? The angle between 7.5 and 6 has to be first on each of them. So triangle F, and then B corresponds to the angle between 6 and 4.5. So FD, and then the last angle is E, by side, side, side congruence. We're going to organize this into a flowchart. You've done these in IM1. Today we're doing them in IM2. The first two flowcharts we're going to do are going to be complete repeats from IM1, and then the third one will introduce a new idea. Okay, so let's start with our proof. We're proving triangle ABC is congruent to triangle FDE by side, side, side congruence. Remember, each box needs justification. That's super important. Examples of justification by SSS congruence, that's the justification, or it might be, say, given, which is the one we're going to use. Okay, I like to go backwards. That's why I started with my conclusion. This is the conclusion. And here in this column, I'll be doing evidence. Just like if you're writing an essay, you need evidence before you can draw a conclusion. So what are the side, side, sides? How can I claim that? Let's do AC. Side length AC equals side length FE equals 7.5. That is given. Given is my justification, and my statement is that the side lengths are equal. All right, BC and ED are equal. BC equals DE. Those equal 4.5. That's given. You usually wouldn't include the numbers, but I want to be super clear what I'm talking about. Lastly, AB equals FD equals 6, and that is also given. This is a complete proof. This flowchart is a proof. Okay, 213. Make a flowchart showing that the triangles below are congruent. Well, if they're congruent, they have to have a congruence theorem. I have a side and an angle in sequence. Side, angle. What's next? In sequence, I have another angle. So I'll be doing side, angle, angle, congruence. Note, side, angle, angle, congruence is the same as angle, angle, side, congruence, right? We've got two angles in sequence and a side, which is not included between them. And our congruent statement will be, I'm going to start with angle Q. Triangle Q, then I'll go to P. R is congruent to triangle. If I started with Q, now I have to start with S. Go to the 120 degree angle T, R, by side, angle, angle, congruence. This is my conclusion. I need my evidence. This is my conclusion. I need my evidence. Okay, so I'm going to need a side, an angle, and an angle. I will start with the side because I'll just go in order. Side, angle, angle. So QP is the same length as ST. That's length 6, and it's given. And angle P is congruent to angle T, and that's also given because they have the same measure. And this one I have to be careful about because you can't just call it angle R since there's more than one available angle R, so you need 3 letters. Angle PRQ, remember to keep the vertex as your middle letter, is congruent to angle PRQ, TRS. And that is not given. I know that because vertical angles are congruent. Period. So you always have to have a justification. Often the justification will just be the word given. And for the conclusion, it will be a congruence theorem. But also often you'll need to know that vertical angles are congruent. Or there are other things, and they're going to come up in these notes too. Okay, problem 2-14. Suppose we're working on a problem involving two triangles, triangle UVW and XYZ, and we know that they are congruent. Let's draw those. UVW congruent to triangle XYZ. Write down every congruent statement involving the sides or triangle. The sides are angles that have to be true. Okay, so for sides, we're going to go in sequence. So UV must be congruent to XY. It's congruent to XY. And VW must be congruent to YZ. And ZX must be congruent to WU. Now let's do the angles. Angle U must be congruent to angle X. Angle V must be congruent to angle Y. And angle W must be congruent to angle Z. And I know which angles go with which and which side goes with which because of the fact that the vertices of the triangles are written in sequence. All right. This problem is really, really important. This is going to get us to something called congruent parts of congruent triangles are congruent. I cannot stress enough how super important this is. Congruent parts of congruent triangles are congruent. And it probably just feels like a natural thing to say, but we're going to use that consequence often. Let's continue. Our friend Callie started to prove that the given information in the diagram at right, that given the information in the diagram at right, AB is congruent to CD. Now, Callie forgot to justify her statements, and we're going to help her finish. All right. We know that AD is parallel to CB. It's given. We need to justify each one. And in case you didn't know, these vertical lines mean parallel. Okay, angle C is congruent to angle A. That's also given in my diagram right here. Angle ADB, that one's a little harder. Let's save it for last. Side BD is congruent to DB. We're going to have a special word for this, but for now, let's just say they are the same side. But we're going to come back to that at the end of the notes with vocabulary. So leave yourself a little gap for that. Okay, now the harder one. Angle ADB is congruent to angle CBD. That's what we're going to use these parallel lines for. So we have our friend, these parallel lines, and we have a transversal that cuts it. And we're going to use alternate interior angles to claim that ADB is congruent to CBD. Alternate interior angles. And we would not be able to use these alternate interior angles if we had not already said that AD and CB are parallel. Okay, triangle ADB is congruent to CBD. What do I have? I have an angle and an angle and a side. And what's the sequence? It goes angle, angle, side. So by A, S, congruence. All right. And the last one, now I'm going to say that these sides are congruent, AB and CD. Let me do this in a different color. AB and CD. And the reason I can say this is because congruent parts of congruent triangles are congruent. This is also called CPCTC, so that you don't have to write the whole thing out all the time. Congruent parts of congruent triangles are congruent. I know that the triangles are congruent, so now I can say all their parts are congruent. That's what made problem 214 so important. We've already used this conclusion, but now we're including it as a proof, in a proof. Okay, problem 216. In each diagram below, determine whether the triangles are congruent or not. If you claim the triangles are congruent, Make a flowchart proof justifying your answer. Part A. We've got two triangles, and it looks like they have a side and an angle that we know about, but we're going to need to find something else. I see that they have parallel lines. That gives me a hint that I have to do something with them. So let's see what I can get from this transversal crossing the parallel lines. Hello, alternate interior angles. How are you today? Okay. You know what? I actually want to pause on this and go and get my vocabulary because I want to use really strong vocabulary to say that side AC is the same side for each triangle. So let's pause that and go to our properties of congruence math notes. We just have 3 properties to take care of. The first one is the reflexive property. The reflexive property states that any geometric figure is congruent to itself. So here in our example, we have DB is congruent to DB. Angle C is congruent to angle C. Angle A is congruent to angle A. The next one is the transitive property. That says that if A is congruent to B, then B is congruent to A. That's not the transitive property, everybody. I'm sorry. This is the reflexive property. Ha ha ha. This is the symmetric property. Whoa. Symmetric property. It's symmetry. Okay. I promise to get the next one right. The last one is the transitive property for real. The transitive property. And that states that if A is congruent to B and B is congruent to C, then A is congruent to C. Let's continue. We're going to go over some theorems. These are theorems that are useful for proving congruence. Useful for proving congruence. First theorem, alternate interior angles. We've seen alternate interior angles before. This theorem says if lines are parallel, then alternate interior angles created by a transversal are congruent. Here's the drawing for it. And I want you to be super careful. So suppose I have this diagram. And it is a trapezoid. And we have a transversal right here. Okay, so with this transversal, I can claim some triangles are congruent, but not others. Here. I know that these 2 angles are congruent. Yes. But, and this is a mistake that comes up a lot, I don't know anything about these. No. No. Just be really careful that you're actually doing alternate interior angles to the transversal. Students often get tempted to do this angle, but it doesn't touch the parallel lines, so it's not actually an alternate interior angle, the red one. All right, let's go. Theorem, CPCTC. That's the one we were just talking about when we were doing the problem where first we proved something was congruent, and then we used that to say that the corresponding parts were congruent. In short form, you're welcome to use the letters CPCTC. That in long form says congruent parts of congruent triangles are congruent. And another short form way of writing that is that if your triangles are congruent, then your parts are congruent. Here's a diagram. Given triangles A, B, C, and Z, Y, X, if triangle ABC is congruent to triangle XYZ, then angles A and X are congruent. I'm matching up the sequence. Angle B and angle Y are congruent. And angle C and angle Z are congruent. And AB is congruent to XY. With my eyes, I'm matching up pairs of letters in sequence. So I just did AB and XY. Next, I'm going to do BC and YZ. BC and YZ. BC is congruent to YZ. And then the last one that I'm going to do is looping around the sequence of letters. So I go from the last letter to the first one, CA. CA is congruent to ZX, period. The congruent parts of congruent triangles are congruent, and I can identify from the congruent statement which parts belong to which. Okay, another one. This is the isosceles triangle theorem, and it states that if a triangle is isosceles, then two things are true. Its base angles are congruent, and if the base angles of a triangle are congruent, then the triangle is isosceles. Period. For our diagram, we'll have two isosceles triangles. Well, one isosceles triangle, but we'll write about it in two different ways. If it's isosceles, then those base angles are congruent. And if those base angles are congruent, then it's isosceles. Okay, now that we have all of our theorems and stuff written out, let's go back to that problem we were doing before we took our break. I'll reread the instructions and we'll restart the problem. In each diagram below, determine whether the triangles are congruent or not. And if we claim the triangles are congruent, we're going to make a flowchart justifying our answer. Well, these will be congruent because we have angle, angle, side, and sequence for both. And angle, angle, side is one of our congruence criteria. And we're going to have to use all sorts of fun things to prove this. Okay. We're going to need an angle, and another angle, and a side, and a conclusion. And in a moment, I'll show you why that in itself is almost enough, but not quite. Okay, so let's see. The given angle is that angle B is congruent to angle I want to put that down below once because I know I need to add something here. Okay. Angle B is congruent to angle D, and that's given. And AC, which is a side in each triangle, is congruent to itself. AC. And the word we use for that is reflexive. So something is congruent to itself reflexively. And we have angle BAC is congruent to angle DCA. But that wasn't given, so we need to justify it. Well, we have to justify everything, but this justification will be that they are alternate interior angles, which depends on the fact that we have parallel lines. So if you're going to use alternate interior angles, you must also state that you have parallel lines and connect from that parallel line statement to the alternate interior angle statement. So AB is parallel, side AB is parallel to side DC, and that one is given. So now I have my two angles and my side. It's in the sequence of angle, angle, side, and I'm going to draw my conclusion by bringing these three statements to my conclusion bubble. And my conclusion is that, yes, in fact, the triangles are congruent. Triangle ABC is, in fact, congruent to triangle. Okay, now I have to be careful. Angle A corresponds to angle. This angle corresponds to this angle. So it's vertex A corresponds to vertex C. And then vertex B corresponds to D. And then vertex C corresponds to vertex A. Triangle ABC is congruent to triangle CDA by angle, angle, side congruence. All right, next problem. Let's look at these. We've got two triangles. I see that I have a side, an angle, and another angle. The vertical angle is right there for me. But you know what? These sides aren't helping. They're not the same. So not only are these not necessarily congruent, they are definitely not congruent. So these are not congruent since FG is not equal to JI. Okay. Two more problems and that's it. Wow. Okay, part C, these triangles are similarly not congruent because the short leg of one triangle is 2, and the short leg of the other triangle is 3. So I know that the short leg SU is not the same length as the short leg TU. So triangle SUT cannot be congruent to triangle UT, I should say, because I can still put them in sequence, UTV. And then this last one, okay, it looks like I've got two sides and a right angle. I can't say yet if they're congruent or not, but let me go ahead and use the Pythagorean theorem to solve for this third side. So the length of KL squared plus the length of ML, 5 squared, equals 13 squared, because this is a right triangle. So it's a right triangle, so I can use the Pythagorean theorem. So whatever that is, KL squared, that plus 25 should equal, is 13 squared 169? I think it is. I'm going to go with it. I hope I'm right. Minus 25 on both sides. Then KL squared equals 144. I take the square root, both sides, and that tells me that KL is length 12. And since it's length 12, I have the hypotenuse and the leg, and one leg being congruent for a pair of right triangles. So for hypotenuse leg, I need just two things. Let's see. Just the hypotenuse and the leg. Hypotenuse, leg, conclusion. So KM is congruent to RQ and is hypotenuse. And that's given. And KL is congruent to PR. And that is a combination of given and Pythagorean theorem. Those come together to let me say triangles KLM and triangle RPQ are in fact congruent by hypotenuse leg congruence. And I realized this would have been easier to see if I had drawn this a little bit higher, but that's hindsight. And yeah, that was the last problem. So I hope you found this helpful, and I'll see you next time. Thanks, everybody.